In this presentation, we will learn how to delete the intermediate node of circular doubly linked list. So let's get started. Now let me show the initial state of circular doubly linked list. This is how it looks like. We have 3 nodes in circular doubly linked list and tail pointer is currently pointing to the last node of this list. Okay. Our target is to delete the node at position 2. Please note this down, that our target is to delete the node at position 2. That is, we want to delete this particular node. For this purpose, I'll first declare a temp pointer which must point to the first node of this list initially. Okay, that's why struct node star temp must be assigned with tail next. Here you can see the temp pointer is currently pointing to the first node of this list. I will use this pointer to traverse this list. For this purpose, I'll use this piece of code. That is, while pos greater than 1, temp equal to temp next, pos minus minus. Here this condition is written, that is pos greater than 1. We have a pos variable which is holding this value 2. I want to delete the node at position 2. For this purpose, I want to move this temp pointer towards right. And I want this pointer to point to the second node of this list. That is the node we want to delete. For this purpose, I am using this piece of code. And here the condition has to be pos greater than 1. Currently pos is containing 2. So here it can be replaced by 2. 2 is greater than 1, right? Condition is satisfied. We get inside. We will move our temp pointer towards right after this. After this, pos will get decremented by 1. That means 2 will get replaced by 1. We know that 1 is not greater than 1. Condition is not satisfied. So we'll get outside of this while loop. So that's all what we need, right? Our temp pointer is pointing to the node we want to delete. After this, I'll create one more pointer temp2 which must point to the node just before the node we want to delete. I'm keeping temp2 pointer which must point to the node just before the node we want to delete. After this, I will use this temp2 to update the next part of this node so that it can point to this particular node. The links has to be updated. The next part of this node must be updated by the address of this node, and the prev part of this node must be updated by the address of this node, right? Then we can delete this node very easily. That is why, in order to update the next part of this node, I shall put this line of code, that is temp2 next equal to temp next. This will update the next part of this node. Isn't that so? After this, I can use temp pointer to update the prev part of this node. That is temp next prev. Temp next prev. It must be updated by the address 1000. We know that this address is contained within temp2 pointer, so we can use this. So temp next prev must be updated by temp2. That means we can replace this address by 1000 address. Isn't that so? After this, we can free the node. That is, we can delete this node without any problem. And this is the resultant linked list so obtained, right? The time complexity is definitely big O of n because traversal is involved. So this is the time complexity, that is order of n. Now let me show the complete code in code blocks. So here is the complete code. We have struct node, we have add to empty function, add addend function. Then we have this del inter function. Okay, to this del inter function, I'm passing tail pointer as well as the pos variable. Here inside, I have declared a temp pointer which is initialized by tail next. And then we have this while loop which we have already seen for traversal purpose. Then we have this temp2 pointer declared over here which must be initialized by temp prev, right? That is the node before the node we want to delete. After this, we will update the links and finally we will free our node. After this, I'm also checking this condition. If temp is equal to tail, that is the node we want to delete is the last node of the list, then we have to update our tail pointer as well. Okay, everything is similar when we delete the last node of the list, but there, in that case, we have to update our tail pointer. Tail pointer points to the last node of the list. If we delete the last node, then it must point to the second last node of the list. Isn't that so? Therefore, after deleting that node, tail must be updated by the address of the second last node. We know that the address of the second last node is contained within temp2. If the node we want to delete is the last node of the list, then we know that the address of the second last node is stored within temp2. So we can use that to update tail pointer. After this, we'll simply return tail back to the main function. Here you can see this is the main function. Here these 3 lines of code will help us in creating the linked list. After this, I'll print this message list before deletion. Then print function is called to print the list. then del inter function is called to delete a particular node. Here, position 3 is provided. I want to delete the last node of this list. After this, we'll simply print this message list after deletion, and then print function is again called to print the list. Let me execute this code. So here is how list before deletion looks like, 34, 45, 56, and list after deletion is 34, 45. Let me just change this to 2. List before deletion is 34, 45, 56. List after deletion is 34, 56. That means this node is deleted. Okay friends, this is it for now. Thank you for watching this presentation.